welcome to your first set of video notes in biology. I am Mrs. Gilpin. You will be also seeing the other fabulous biology teachers, Ms. Kaiser, Ms. Ramsey, and Mr. Yasichek throughout the video notes. We are going to be looking at notes in chapter section 1.1 in your book. Also, as you are watching the videos, please make sure that you're taking your Cornell notes down. The topic today is collecting and interpreting data. The central question is explain why scientists create graphs to show data. So the first thing we're going to talk about are controlled experiments. What does it mean to have controlled experiments? That is when you're testing your hypothesis and you're only changing one variable. So one thing in your experiment is being changed. And those are the type of experiments that we will conduct in biology class this year. So if you look at this picture below, we are designing a controlled experiment. Here we've separated two plots of the same type of grass, same soil, same everything. And the next set of pictures over here, we are manipulating one of the sets of grass and we are adding nitrogen to it. That is how this experiment is controlled. We are just changing one variable, the nitrogen that we added. Now in this experiment, we're adding nitrogen because it's a component in fertilizer, and we're going to see how that affects growth in these plots of grass. Okay, so the one plot of grass that we are manipulating, we're going to call that experimental group. That's the plot of grass that we are purposely experimenting with to see effects of this nitrogen. The other plot of grass off to the side of it is called the control group. We do not change or manipulate that. It's kept constant, and that allows us to compare how the experimental group is changing based on the nitrogen that we added. We're also going to talk about independent and dependent variables. Independent variable in this experiment is the one thing that we as scientists are changing, that we are manipulating. The dependent variable is what in our experiment is responding to the change. So let's reflect back on this experiment. We're going to apply what we now know. So in the experiment above, we first want to identify the independent variable in the experiment. So what did we purposely change in our plots of grass? One plot of grass has nitrogen added to it. That would be the independent variable. The second thing we want to identify here is the dependent variable. So what is responding to the nitrogen added? And in this experiment, we would be looking at how plant growth of the grass is being affected.
Nice.
All right, so Mrs. Gilpin was just talking about the difference between a control and experimental group, and so we wanted to represent that in a Venn diagram. So if you could draw a Venn diagram on your notes, pause this video for a moment so you can do that. Okay, now that you have a Venn diagram, one side is the control group, one side is the experimental group, let's talk about the differences between the two. So in a control group, in the experiment above that Ms. Gilpin explained earlier, between the grass with no nitrogen and the grass with nitrogen added, the control group would be the experiment where no nitrogen was added. And then on the experimental group side, the differences between those would be that you added nitrogen to that experiment. Now the similarities between both the control group and the experimental group could basically be unlimited. You could have millions of things that both experiments have together. But in this example, some that we've listed are they both have the same grass seed, they both have the same type of soil, they both have the same amount of sunlight, and they both have the same amount of water. So that is kind of comparing and contrasting the similarities and differences between a control group and experimental group in this example of this experiment. All right, so we need to talk about when you're collecting data in your experiments. You have your control, you have your experimentals, but you need to talk about the types of data that we will be collecting in this class. So you may be familiar with these words. They both start with Q. The first one is quantitative data. Quantitative data is data you collect with numbers. So measurements, counting. So if you have 3 centimeter length growth versus 12 centimeter length growth, that is examples of quantitative data. When you are looking and collecting qualitative data, that's the second type of data. Qualitative data is using words to describe what you see, what you're observing. So color, shape, writing sentences and describing the characteristics you see instead of numbers.
All right, so now you've collected a bunch of data in your experiment, but what do you do with it? Data needs to be organized so that it can be useful. If you want to make a graph later, data tables work great to be able to do that. So there's a couple things you need to do in making data tables. First of all, you need to have a specific title. What is it you're talking about? Usually it's a good idea to mention either your independent or dependent variable in your title. You want to determine the type of information. Are we talking about qualitative, quantitative data? You want to be aware of that. You might need units if you're talking about quantitative data, for sure. How do you want to measure? You want to label units correctly. Okay, so this needs to be noted in your data table. And deciding number of rows, deciding number of columns, that should play out depending on how much data you have, how many data points, variables you're dealing with. Here's an example of a data table, and you can see it has a very specific title, Effective Sugar Solution on the Height of Plants. You might want to take a minute here and think about, okay, which one of these is the independent, which one of these is the dependent variable? Which one are we manipulating? Which one are we changing? So hopefully you can see here that we are in fact changing the percent of sugar solution from 0 to 50%. And that would be our independent variable, right, because we're manipulating it, and we want to see what effect that has on the height of plants over time. That would be our dependent variable. Okay, now we're going to take a look at how we might graph this data.
All right, so now that we have our data and we've collected it, now we need a way to analyze it. So the way we do that is we put it into a graph, and that is how we analyze our quantitative data. So in order to make a good graph, we need a specific title. What are we looking at? The second thing we need is we need to determine if it is a line or a bar graph. And all the time, every time that you do anything that looks at change over time, you always want to do a line graph. And then you need to determine your axes. Make sure you label them. That is very important. So on the x-axis, you want to put your independent variable, and then on the y-axis, you put your dependent variable. And then always have a key when it's needed. And you need a key when you're looking at more than one variable on your graph. All right, so here's our data that we collected. And the experiment we were looking at is we were looking at this plant hormone called ethylene, and it causes fruit to mature. The data above concerns the amount of time it takes for fruit to mature from time of the first application of ethylene by spraying a field of trees. So we're looking at a change over time situation here, so we are going to need a line graph, and when we make our line graph, we need to determine what is the independent variable and what is the dependent variable. So just taking a look at our data here, take a second, pause the video, and see if you can determine what is the independent variable and what is the dependent variable. And then after that, you also need to make sure what kind of specific title you are going to use with this data, graph and the data that we have. So if you took a second to pause the video and determine what the title would be and what your independent and dependent variable will be, you should have gotten something around this for your title, the maturity of apples when sprayed with ethylene. That is what we are experimenting with. That is what we're looking at. And so this is going to be a change over time, so we are doing a line graph here. And let's take a look at what we have on our x-axis. And remember, the x-axis is our independent variable, and our independent variable is ethylene amounts on apples, so the amount of ethylene that we sprayed on apples. And now the dependent variable, this is the variable that's going to depend on the amount of ethylene sprayed. That is what we're looking at, change over time. And we have days of maturity on our y-axis. So now we're almost set up with our graph. We also would need to then make sure we label with units the amount of ethylene that we are spraying, and also the numbers of days of maturity on there. So take a time and practice using this data from this page making a graph with your labels. Okay, and now remember when you are done taking notes from this video, you need to answer the questions on the Google form. Go online, and your first question is going to be, what is missing from this graph? So take a look at this graph, figure out what is missing. And your second question to answer on the Google form is, why is it important to create a data table? And remember, this Google form is found on the class website. Find it, fill it out, make sure you put all the information you need. We will be checking it, and good luck.